Hello, this is Clair Sullivan. I'm a scholar at the Data Incubator, and this is my week 4 video on my project Snow Stats. Just going back to the question we're trying to answer is, can we predict snowfall for ski areas in advance of the season to help with their marketing campaigns? We will be using Landsat overhead satellite imagery to historically analyze snowfall as a function of different weather parameters prior to the start of a season. The biggest challenge I've been facing is just the amount of storage that Landsat imagery takes. For instance, if I had one scene, which is 160 kilometers on the side, one image for that will be 55 megabytes, but then there are 7 different spectral bands for most Landsat satellites. One image every 16 days times 43 years worth of collection, that means 377 gigabytes per scene. Using the DigitalOcean machines available to us at the Data Incubator, that's more than we can really handle. So this week's challenges were how to filter the data before downloading it so I didn't exceed my quota. So I created filters based on cloud coverage. We can't analyze Landsat on cloudy days. I also filtered out just where are the winter months. And once we did that, we scraped the data and calculated the NDSI as I've shown in previous weeks. And then for any given ski area, I only wind up with about 100 data points to look at. So here's an example of some of my results. This is looking at the Taos Ski Valley for the time range 1984 to 1997, and looking at the El Nino conditions measured as ENSO, which is El Nino Southern Observations. And what you see, strong El Nino years are in red, weak El Nino years, or La Nina years, are in blue. And I was hoping to see a correlation between the percent coverage snowfall shown on the y-axis along with El Nino. And these results don't quite bear that out. But with only 100 data points, this is not quite telling the entire story. So the next steps are to scrape more data to be able to add into this, and then we can start thinking about some machine learning. Whether we do regression versus classification is still an open question. With this few data points, we don't really have enough to do anything more complicated than a stochastic gradient descent, and perhaps some sort of support vector machine to separate good snow year from bad. Also, we could look at the time variations of the ENSO measurements other than looking at just the months December, January, and February, and we could perhaps consider this in some sort of grid search approach. Thank you for watching, and I hope to see you on the slopes.